So yesterday we started this handout, section 3.2, division of polynomial functions. And what we did yesterday, just as a reminder, is we learned or reviewed, depending upon the situation, right, how to divide two polynomials using long division. Okay. And so most of the time, when you divide two polynomials, you have to use long division. There's only one special case where you can use synthetic division, okay? And that's when the divisor has x to the first power. If the divisor has x raised to a higher power than x to the first, right, then you got to use long division, and that's more complicated than synthetic division. Okay. All right, so we reviewed that yesterday. So if you flip over your page, we're going to talk about the remainder theorem, and then we'll talk about synthetic division. Okay. So the remainder theorem says if a polynomial function f of x is divided by a linear polynomial, x minus c, as x to the first power, right? This is what makes it linear. Right? Is divided by x minus c, then the remainder from that division is the value of the function f of x at x equals c. That is, you just evaluate f of x, you just evaluate f of c, and that's equal to the remainder. So you don't actually have to do the division to know what the remainder will be. Okay? You have to do the division to find out what the quotient will be, but you don't have to actually do the division to see what the remainder will be. Okay? So in example 3, says use the remainder theorem to find the remainder R when f of x, the third degree polynomial, is divided by x minus 3. Okay. So we're taking the polynomial using notation from yesterday, 2x cubed minus 5x squared plus 4x minus 6. And we're dividing it. Remember, fraction bars are like division symbols. We're dividing by x minus 3. Okay. So if we perform that division, what's the remainder going to be? We don't actually have to do the division. Okay. F of x is equal to the numerator. And x minus c in this case is equal to the divisor x minus 3, which means c is equal to 3, okay, from the remainder theorem. So all we have to do is evaluate the function f of x at x equals 3 to determine what the remainder would be if we did this division. Okay. And so the remainder R for this problem is equal to f of 3. And to evaluate f of x at x equals 3, we just put 3 in for x on the right hand side. And we have 2 times 3 cubed minus 5 times 3 squared plus 4 times 3 minus 6. And when you do that, now to do that arithmetic, you got to follow the order of operations, PEMDAS. And when you do that, you get the remainder is equal to 15. So if we divide f of x here by x minus 3, after we do that division, find that our remainder is 15. Okay. Example 4 says use the remainder theorem. Were there any questions on this? What we just did? Okay. Example 4 says use the remainder theorem to find f of c for f of x equals that fourth degree polynomial when c is equal to 1/2. So in example 4, we're taking the fourth degree polynomial 3x to the fourth minus 5x squared plus 2, and we're dividing by x minus c, which is x minus 1/2 in this case. Okay. C is equal to 1/2. So what's the remainder when we divide this fourth degree polynomial by x minus 1/2? Well, it's equal to, let's remind ourselves, f of x is equal to the numerator, 3x to the fourth minus 5x squared plus 2. And so if we divide f of x by x minus 1/2, the remainder will equal f of 1/2, right? We just evaluate f of x at x equals 1/2. And to evaluate f at x equals 1/2, right? We just put 1/2 in for x on the right hand side. We have 3 times 1/2 to the fourth minus 5 times 1/2 squared plus 2. And again, you got to do PAMDAS, right? And you're doing that arithmetic. And you get the remainder is equal to 15/16. Okay. So if we divide this fourth degree polynomial by x minus 1/2, we would discover that the remainder is equal to 15/16. Okay. Any questions on that? That's what the remainder term tells us. Now we don't know what the quotient is, okay, but we know what the remainder is. Okay. All right. So now let's talk about synthetic division. And synthetic division allows us, right, a shorthand method of dividing a polynomial by a linear polynomial. Okay. Synthetic division is a shorthand method of dividing a polynomial f of x by a linear polynomial x minus c. And again, what makes x minus c a linear polynomial is that's x to the first power. If that was x squared or x cubed or x to the fourth, we wouldn't be able to use synthetic division. Okay. And with synthetic division in this special circumstance, right, we don't have to do the long division, right, involving the variable x. We only need the coefficients from the polynomial and the value of c to perform the synthetic division, right, to divide the polynomial by the linear polynomial x minus c. Okay. Now riddle me this. Either in college algebra and high school algebra, how many of you remember being exposed to synthetic division? Okay. Several of you, right? So for a lot of you, this is just review, probably. Okay. And for the rest of you, okay, it's a good time to learn this technique. Okay. All right. On example 5, it says use synthetic division to find the quotient and remainder when f of x is divided by x plus 4. Okay. So we have the fourth degree polynomial, x to the fourth minus 14x squared plus 5x minus 9. We're going to divide that by x plus 4. Okay. I'm just kind of sticking with the notation from page 1, right? So you can see the connection. Okay. Now, the first step in doing synthetic division, what is C? Well, C is equal to minus 4. Okay. Remember, maybe let's write this out. X minus C is equal to X plus 4 in this case. And so when you solve for C, you get C is equal to minus 4. Right? You have to change the sign. No. The first step then is to put C in a box like that. Okay. And then we write out to the right of that box, we write out the coefficients of the polynomial. And the coefficient for x to the 4th is 1. Now let's write out up above the power of x for each of these coefficients. So we got x to the 4th, then we got to write these out, these coefficients in descending powers of x. So x to the 4th is the largest. So then the next one is x cubed, then x squared, then x to the 1st, then x to the 0, which is 1. Okay. So the coefficient that goes with x to the 4th is 1. You notice there's no x cubed term in here. Okay? That's because the coefficient that goes with x cubed is 0. 0 times x cubed is 0. So we put a 0 here for the coefficient for x cubed. Coefficient for x squared, minus 14. Coefficient for x is 5. And the coefficient for the constant term is minus 9. Okay. Leave a space, an empty row, draw a horizontal line. Okay. All this is on video. If this is your first time learning synthetic division, right, you can, if you miss something, right, you can review the video. Okay. First step, bring the 1 down. Second step, multiply 1 by minus 4. With minus 4 times 1, which is equal to negative 4. And we put the negative 4 in the second column under the 0. Now we add 0 to minus 4 and get minus 4. So the only mathematical operations we're doing are multiplication and addition. Nothing else. It's multiplication and addition. Okay. So we add 0 minus 4 to get minus 4. And now we multiply minus 4 times minus 4, and we get 16. That result goes in the next column, and we add 16 to negative 14 and get 2. You should see the pattern, right, that is emerging here. Now we multiply 2 by negative 4 and get negative 8. That goes in the next column. Negative 8 plus 5 is negative 3. Now we multiply negative 3 by negative 4 and get 12. And now we box the last number. Okay? And minus 9 plus 12 is 3. This number that goes in the box under the last column, bottom of the last column, is the remainder. So our 4th degree polynomial divided by x plus 4 has a remainder of 3. Okay? And we would also have just known that if we had evaluated the numerator here at x equals 3. If you put 3 in for x in the numerator, the value of the numerator, excuse me, I said that wrong. C is equal to minus 4. If we had evaluated the numerator at x equals minus 4, the value of the numerator would equal 3, which from the remainder theorem tells us what the remainder is when we divide this by x plus 4. Okay. All right. So the quotient, to find the quotient, these are the coefficients for the quotient. And starting from the right-hand side, the minus 3 goes with x to the 0, right, which is 1. That's the constant term. 2 goes with x. Minus 4 goes with x squared. And 1 goes with x cubed. Okay. So you multiply each coefficient by its variable x. And we have the quotient q of x. Actually, it's a small q, not a big q. 1 times x cubed is x cubed. Then we have minus 4 times x squared. Then we have 2 times x. And then we have minus 3 times 1, which is minus 3. Okay? So the quotient is x cubed minus 4x squared plus 2x minus 3. And the remainder r is equal to 3. Okay. That's the shorthand answer, right, to this problem. Okay. Let me show you what we have discovered. The 4th degree polynomial x to the 4th minus 14x squared plus 5x minus 9 can be written as the divisor x plus 4 times the quotient x cubed minus 4x squared plus 2x minus 3 plus the remainder 3. That's what we have discovered, right? So this is f of x, which we often call the dividend. This is the divisor. So this is sort of a rehash from yesterday, right, of terms. That's the divisor d of x. This is the quotient q of x. And then this is the remainder. And with synthetic, when your division divided by a linear polynomial, the remainder r won't be a function of x, so it'll just be equal to a real number. So this is kind of layout from yesterday, right, when we were doing long division. All right, so any questions on that, ladies and gentlemen? Yes, ma'am.
How do you want us to write it when it's like auto test?
Write what?
Like the answer.
Well, in this one it just said to find the quotient and the remainder, right? So you would write this is the quotient, and this is the remainder. And there'll probably be a blank, right, on the test for you to fill in the blank with your answer. Okay. Yeah. I added this because I wanted you to see what it is we've accomplished here. Okay. Sometimes students can't make the, right, it's important to make the connection between the answer and what it is that we've accomplished here. Okay. All right, so let's take a look at B. So we're gonna divide the fourth degree polynomial, 8x to the fourth minus 30x cubed plus 23x squared plus 8x minus 3 by the linear polynomial x minus 1/4. Okay. So you can see, right, x minus c is equal to x minus 1/4. So you can see that c is equal to 1/4 in this case. So 1/4 goes in the box. And then to the right of the box, we write out the coefficients of the polynomial descending powers of x. So we have x to the fourth, x cubed, x squared, x, and x to the 0, which is equal to 1. Coefficient for x to the fourth is 8. Coefficient of x cubed is minus 30. Coefficient for x squared is 23. Coefficient for x is 8. And the constant term is minus 3. Then we leave an empty row and draw a line. So first step, bring down the 8. And then we multiply 8 by 1/4. And 1/4 of 8 is 2. So the result 2 goes in the next column. We add that to minus 30. And we get minus 28. And now we multiply minus 28 by 1/4, which is equal to minus 7. Minus 7 goes in the next column. Minus 7 plus 23 is 16. And now we multiply 16 by 1/4 and we get 4. And 8 plus 4 is 12. Now we multiply 12 by 1/4 and get 3. And since this is the last column, right, we box this number. And minus 3 plus 3 is 0. That's the remainder R. Okay. So to get the coefficients for the quotient, you start with the right-hand quotient, right? That goes with x to the 0, which is 1. Right? That's the constant term. 16 goes with x. Minus 28 goes with x squared. And 8 goes with x cubed. So the quotient q of x is equal to, right? We multiply the coefficient times its x term. So we have 8 times x cubed minus 28 times x squared plus 16x plus 12 times 1, right, which is 12. So that is the quotient from performing this division, right, of that fourth degree polynomial by that linear polynomial. And the remainder from the division is 0. So if you evaluated the numerator at x equals 1/4, it should equal 0 from the remainder there. Okay. So what we have discovered is that our fourth degree polynomial, 8x to the fourth minus 30x cubed plus 23x squared plus 8x minus 3 is equal to the divisor x minus 1/4 times the quotient 8x cubed minus 28x squared plus 16x plus 12. And the remainder is 0. So this is the quotient, this is the divisor, and this is the dividend. Okay. The function, the polynomial f of x, in this case is equal to the divisor x minus 1/4 times the quotient. So we actually partially factored this polynomial. Okay. X minus 1/4 is one of the factors of this 4th degree polynomial. Now we would have to factor this 3rd degree polynomial to finish the factoring. Okay. All right, any questions on that? Yes, sir.
So, on the test, after we work out the first part, would you want us to write out like what you just did? Would you want
Here?
us to, yeah. Would you want
If
us
you're
to-
instructed to.
Okay.
Yeah. I'll probably leave you a space, right, to write out the dividend in terms of the divisor, the quotient, and the remainder. Okay. Yeah. But these particular problems, you were only actually instructed to find the quotient and remainder. I just wanted you to see the connection between the quotient, the remainder, and the divisor to the original polynomial f of x. All right. No other questions? Example 6 says use synthetic division to find the value of k such that f of x is equal to kx to the 4th plus 7x squared plus 4k is divisible by x minus 1. Well, so we have a polynomial is f of x is equal to kx to the 4th plus 7x squared plus 4k. Our divisor d of x is x minus 1, which means c is equal to 1. Now I'm going to set this up for you, but I'm not actually going to solve this problem using synthetic division. I think that's the long way. It's faster just to use the remainders there. Okay. So to set this up using synthetic division, right? 1 goes in the box. And then what are the coefficients for a 4th degree polynomial? Well, we've got x to the 4th, x cubed, x squared, x to the 1st, and x to the 0, which is 1. And so the coefficient for x to the 4th is k. It's 0 for x cubed. It's 7 for x squared. It's 0 for x. And it's 4k for the constant term. Okay. And now you perform synthetic division, right? Bring down the k and so forth. Okay. Well, the remainder theorem says the remainder r is equal to the value of the function f of x evaluated at c, which is 1. Right? So the remainder from dividing f of x by x minus 1 is equal to f of 1. Okay? All right. And if f of x is divisible by x minus 1, its remainder is equal to 0. Okay? So if f of x is divisible by x minus 1, then its remainder r is equal to 0. Okay. And so when you do the synthetic division, you get your remainder r, right, is in terms of the variable k, or the constant k, and you gotta set the remainder equal to 0 and solve for k. Shorter method is just to evaluate the function f of x at x equals 1, and then set it equal to 0, so that the remainder is equal to 0, and then solve for k. You end up doing the same thing, just different ways. Well, f of 1 is equal to k times 1 to the 4th plus 7 times 1 squared plus 4k. Remember, putting in 1 in for x. And so when we simplify, 1 to the 4th is just 1, so we have k times 1, which is k. 7 times 1 squared is 7. And then we have plus 4k. And so the remainder r is equal to 5k plus 7, depending upon what the value of k is. Well, in order for f of x to be divisible by x minus 1, the remainder r has to be 0. So we replace r with 0, and then we solve for k. And when you solve for k, you get k is equal to minus 7/5. So if k is equal to minus 7/5 in this 4th degree polynomial, okay, this 4th degree polynomial will be divisible by x minus 1. Okay. And you get the same value for k, whether you find it using synthetic division or using the remainder term. Okay. Get the same value of k. All right. Any questions on this? So you have everything you need to complete the WebAssign home